I don't know, I'll try to upload it, but honestly, it's really hard to upload these lessons. So
yes, don't put pressure on it.
Let's see, pause. Okay, so I think it's recording. A linear equation, the parent, so usually we say it's y equals mx plus b, right? Well, it's just really y equals x. I mean, we could put mx, but let's just put y equals x. That's the parent equation. Y equals x is just the line that goes, let's put a circle through here because this is our locator point, has a slope of 1, and it looks like this, down 1 over 1. I'm just kind of doing a quick one. This one I don't want to spend too much time on because linear functions, come on, that's math 1 stuff, right? So, but if I shift this graph around, if I want to shift it up or left or right or down, then that's when I add like a b. But instead of saying b, we're going to put y equals m times x minus h plus k. Okay, so that is the transformed function. And I wanted to do something. Oh, I know what I wanted to do. I wanted to stop my video so I don't use up all my video, my bandwidth. Okay, so let's put an example equation. Let's put some numbers in here. Y equals -2 times x minus 1 plus 3. Okay, this is our example. We're going to graph it right here. So this is our parent graph right here. This is what like y equals x looks like. If I want to shift it around and put a -2 in front, that's going to be my slope, right? -2. And this is my hk. So your hk, you want to name what hk is. Where can I put hk? I'm just going to put hk right here, just because there's room right here. Hk, again, is your locator point, right? Locator point. Talked about that. So right now the locator point is 0, 0. That's why we put it right there. Well, now we're going to shift it over. We're going to take the opposite of -1, which is +1, and go up 3. Okay, so if I go to 1, 3, that's like right here. I'm going to put a circle around that point. Really, it's filled in, but to indicate that as locator point, I'm just going to put like an open circle, even though it's closed. The slope is -2, so I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and make a line through there. I'm going to use the line function here. Boom. Oops, make the line longer. Up 2 over 1, up 2 over 1, that way. Okay, and so draw arrows at the end like that. So that's how you shift a line, right? So it's been shifted from like 0, 0 up to 1, 3. And then, and my slope is opposite because we made the slope negative. So that's just a linear graph, okay? Domain is all real numbers. Let's write domain, all real numbers. And the range is all real numbers, okay? Very easy. Okay, let's move on to the next one. Next one we're going to do is absolute value. Ooh, I need to move this up. Okay, so I'm going to have to clear this drawing because I have to move the paper up. So hopefully you have that down. Give you a couple seconds before I clear it. If you're okay, hopefully you guys have that down. Got to clear that, got to move this up. Erase my mouse, okay. And annotate. Okay, so next one we're gonna do is absolute value. I guess I could have used the same graph since I erased it, but I want you to write it in the right place. So I'll use this one down here. Absolute value, so this is graph number 2, right? Parent function of absolute value is y equals absolute value of x, like so. Okay, if I put in 0, I'm going to get 0. If I put in absolute value of -1, I'm going to get 1. Absolute value of -2 is 2. Absolute value of -3, 3. Absolute value of 4, 4. Absolute value of -5, 5. Absolute value of 1, 1, 2, 3, 4, 5, right? If I put those numbers in there, that's what we're going to get. No negative numbers, right? Because this is absolute value. So my locator point, again, is at 0, 0. So I'm going to put like an open circle there. I'm going to go up 1 over 1, 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 because that is where 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 are. So the right half of the graph is a line like this with an arrow going on forever. And then the left part of the graph is negative 1, 1 over here, negative 2, 2, negative 3, 3, negative 4, 4, negative 5, 5. So we draw a line up here. Sorry, my line is crooked. It's hard to draw with this. And that is what an absolute value graph looks like. It's a V, and my locator point is 0, 0. Okay, locator point 0, 0. Okay, if I want to transform this, the equation is going to be y equals a times x minus h, absolute value plus k. So the h goes with the x, right? The h always goes with the x. The absolute value bars are there. A is going to like either make it narrower or wider v. Okay, that's what the a does. If the a is greater than 1, it's going to be narrow. If the absolute value of a is in between 0 and 1, then it's going to be wider. Okay, I need to erase that though, because I need to put a function here. So function, back to writing. So I need to put a transformed function. So let's put y equals 1/2 times the absolute value of x plus 3 minus 1. Okay. So where's our HK? Where's our locator point? I'm going to put HK right here, H comma K, just because there's room there. That is our locator point. I'll put LP for locator point, right? LP. So my LP, we're going to take the opposite. Remember, your H is here, the opposite of H is here, and K is here. So the opposite of positive 3 is negative 3. And then that number at the end has been shifted down 1. So we're going to the left 3 and down 1. So 1, 2, 3, down 1 is right here. And let's see, our A is positive, right? If A is greater than 1, it means it's going to point up. And this is actually our slope. And you know, we could make a table, we could put numbers in here and make a table, but our slope should be up 1 over 2, up 1 over 2, up 1 over 2, because your A is your slope. You know, you could write that down. A equals the slope. If it's negative, then we'd have a negative slope. So this is my right side, and sorry, I should have made that an open circle right there. And let's label the locator point, negative 3, negative 1. And then so up 1 over 2, up 1 over 2. I kind of ran out of space here, but it's like that. Okay, we can make a table and everything. Our domain is all real numbers because it goes to the left forever, it goes to the right forever, so all real numbers. Our range is not all real numbers. It goes from negative 1 up. So y is greater than or equal to negative 1. Does this have symmetry? Does it have asymptotes? No, it does not have asymptotes, but it does have symmetry, right? It has a vertex and it has a line of symmetry. Line of symmetry. Symmetrical. The left side is symmetrical to the right side. If I wanted to draw a line of symmetry, I could draw a line down the middle, but we don't do that for absolute values. Vertex is a maximum or minimum. Let's write that. So it does have a vertex, right? And in this case, it's the minimum. If it was pointing down, then it would be a maximum. So vertex is max or minimum. So there's a maximum point or a minimum point. In this case, we have a minimum point. It's the vertex. The vertex is at negative 3, negative 1, which is also the locator point. Describe where the transformed locator point. So the locator point is the vertex, which is at negative 3, negative 1. That's my vertex / locator point. Okay. All right, so give you a second to finish copying that down while I, before we move on to the next one. 2 down, at least 2 more to go.
I I didn't get the first table, but I got the rest. I
That's
don't know
fine.
what to put in the first table.
That's fine. The first table, I just put 0, 0 in there.
Okay.
Okay, we good to go on to the next one, guys? Okay, so I'm gonna go back up to the top. So this would be a new page, right? So you have another page here. I'm gonna go back up to the top. Our next equation is a quadratic. So quadratic, which we've done lots of now. We did at the end of math 2 and a lot for chapter 1. Parent equation, y equals x squared. Okay. We know that this starts at 0, 0. So I'm going to put up my locator point, open circle at 0, 0. And then, so 0, 0. When I put in 1 in here, I get 1 squared is 1. Negative 1 squared is also 1. When I put in 2 in here, 2 squared is 4. Negative 2 squared is also 4. When I put 3 squared, I'm going to get 9. And negative 3 squared is also 9. When I square 4, I'm going to get 16, and negative 4 squared is also 16, and 5 squared is 25, and so is negative 5 squared is positive 25. Okay, when you get really big numbers like 15 and 16, people always go, oh, it doesn't fit on the graph. Then don't put it on the graph. Just put the ones that fit on the graph. Okay, so like these ones are going to fit on the graph. 0, 0, negative 1, 1, positive 1, 1, and then we go over 1 up 3, over 1 up 3, and then over 1 up 5. You know, I could go 2 more up 5 up like there, right? And so this is a parabola, nice U-shaped parabola. Pen is not working so well there. There we go. Okay, does this have symmetry? Absolutely, it has symmetry. It has a line of symmetry, right? So we have, you know, we can write an equation for that line of symmetry. It has a maximum or minimum. Yes, this has a minimum right here. It has a minimum, min or max, depending on if it's up or down. Right, so right here, this is a minimum. And my equation, should I want to shift it around, is y equals a times x minus h squared. Don't forget it's a squared because it's a parabola, plus k. You should know this formula kind of by heart now. We've been doing it a lot. So let's put some numbers in for a, h, and k. Y equals negative 1/2. That's going to make our parabola do something. Times x minus 1 squared plus 3. Okay, so this is what we're going to graph over here. And we'll write the domain and range for this over here. All right, what is our locator point? Our HK, I'll write it, I guess we could write it right here. HK is, so here's the opposite of the H, right? It's with the X inside the parentheses, and here's your K. So opposite of -1 is +1, and that 3 at the end is your K. So 1, 3 is the locator point. So I'm gonna go to 1, 3, which is up here, put a circle at 1, 3. Okay, and since this is -1/2, you know, ideally you should probably make a table for this. And let's say I plug in 0 into here, you know, to get my next point. If I plug in 0, I'm gonna write it down here. I'm gonna get -1/2. Don't write it on your paper here, down here, because we're gonna, but I'll do it here. -1/2 times 0 minus -1 is -1 squared plus 3. -1 squared is +1 times this -1/2 makes -1/2 plus 3, which equals, so I'm doing, so in the middle is 1, 3, and then I'm doing 0 and 1 because it's going to reflect. So when I put it in 0, I get 2.5, right? 2.5. So 2.5, which means this is going to be 2.5 because it's symmetrical. So 0, 2.5 is like right next to it, like that, like that. And then I could plug in -1, or I could plug in 3 over here. Let's go ahead and plug in 3. So I'm going to erase this work here and plug in 3. I should have just put a 3 in there. Okay. So if I plug in 3, I'm going to get -1/2 times 3 minus 1 squared plus 3. 3 minus 1 squared is 2. 2 squared is 4. -1/2 of 4 is -2 plus 3, which equals 1. So when I plug in 3, I get 1. Did I do 2? Yeah, 2. Sorry, 2. This should have been 2 right here. There we go. 3, 1. So that means -1 is also going to be 1. So 3, 1 is right here. -1, 1 is going to be right here because it's symmetrical. And I could plug in another point. I could keep going and plug in another point, but my graph is going to go somewhat like this. Okay. I would plug in another point if I had unlimited time, but we don't have unlimited time. So I would plug in like 4 and 5 and keep going like that. Yes. Okay. All right, we good with that, guys? Let's see. Ooh, domain and range. Domain for this, all real numbers, because it goes that way forever, all real numbers. Range goes from here down, so it goes from 3 down. So y is less than or equal to 3. Okay, it does have line of symmetry. The line of symmetry goes through the line, it goes through 1. So that is the line x equals 1. You need to be able to write that line of symmetry for any graph that has symmetry. X equals 1. It's going to be the same as whatever your x coordinate is. That's what the line of symmetry is going to equal. X equals 1. Okay, I'm going to clear this away. And then we're going to move down, move my paper up here to the 4th graph. And number 4 here is cubic equation, cubic. This is a cubic family of equations, and that means x to the 3rd. So y equals x to the 3rd. Okay. So when you get 0 to the 3rd, that's 0. When I put in 1 to the 3rd, that's 1. When I put in -1 to the 3rd, let's talk about -1 to the 3rd. That's -1 times -1 times -1. Is that going to be positive or negative? Well, since there's 3 of them, it's going to be negative. So this is actually going to be -1. When I put in 2 to the 3rd, I'm going to get 8, because 2 times 2 times 2 is 8. When I put in -2 to the 3rd, that'll be -8. Okay. When I do 3 to the 3rd, that's 27. 3 times 3 times 3 is 27. -3 to the 3rd is -27. And then these numbers get really big. Do I need really big numbers? No, they're not going to fit on my graph. So you could put them in, but I'm going to stop there, right? So to graph this cubic, it starts at 0, 0.
Wait,
That's my.
Is this on a different page?
This is
than we
on
just did?
the bottom of the 2nd page.
All right, thank you.
Okay, so this is 0, 0. And then 1, 1 is right next to it. And then it's going to increase faster. It's going to go to 2, 8. So let's number our graphs. 2, 4, 6, and then 8 is like 1 up, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 1 up. So right above here. So this is going to do a curve, and it's going to go higher and higher, faster and faster. It never goes straight up, okay? One person on your guys' slides last week, one person wrote an asymptote like this. There's no asymptote for this graph. Okay, so we don't want to do that asymptote. It's going to keep going to the right. So it's going to keep going like slowly, but increasing to the right. Okay, there's no asymptote. And then here we go, -1, 1. -1, -8, so down here, and then -1, 20, -2, 27. But I don't know if you can see, there's a slight curve, right? So we call this like an S curve. That was like the description that you put. It's a sideways S, like if you turn your head, it's kind of like a Z, but you know, more of an S, like a backwards S, if you turn your head sideways. So that is what this graph, the x to the third cubic, looks like, right? This is our main function here. Forget this stuff. Let me erase that. Okay. So let's transform this. If we want to transform this, I'm going to put y equals a times x minus h cubed, it's a cubic, plus k. It looks just like the quadratic, except there's a cubed. So the point that we're going to move around is 0, 0, right? That's like your vertex. That's your locator point. Okay. So if I put the equation, example equation, y equals 1/4 times x plus 2 squared, cubed, sorry, cubed, minus 3. So that's the numbers we're going to use. Okay, well, from that equation, we can get our HK, our locator point, our LP, locator point. Okay, so we take the opposite of what's in the parentheses here, opposite of positive 2, negative 2. That's our H. This is our H. This is our K. And then this number at the end, we don't take the opposite of because it's not in parentheses. So negative 2, negative 3 is where the middle of our graph is going to be. Negative 2, negative 3 right here. Okay, that's our locator point. That's where like a line of symmetry. This also has rotational symmetry. Let's write rotational symmetry before I forget that. Because if I rotate my paper 180 degrees, if I turn it upside down, it's going to look the same. Rotational symmetry. It doesn't have line symmetry. Like you can't fold it in half, but you can rotate it 180 degrees and it'll be the same. Okay, so if I were to plug in points, I believe I'm going to get, and this 1/4 is going to be really small. It's going to be like really close. So it's going to be like really close, like down here and down here on either side. Okay, and let me label this locator point is negative 2, negative 3. Okay, it's going to curve right there. It changes direction, it curves. And then my other point is going to be 0, negative 1, just because I've done this ahead of time. So if I plug in 0, I'm going to get negative 1. And then the other point goes over here like 2 units down, I believe. Let's see. 1, 2, like right here. Okay. So take a look at those points right there. That's at negative 1, 2, 3, 4, negative 5. So negative 4, negative 5 is where that point is. And then there's another one way up here at 1, like 2.5. 1, 2.5. There's another point. And then there's another point like somewhere down here. Okay, so if I make my graph, here's my S curve. Okay, and that's where my locator point is. I want to make an open circle there, but I accidentally made it closed. So that's your locator point at negative 2, negative 3. Okay, so this graph is a little wider, right? It should be wider because of the 1/4. Okay. So if I were to put negative, then it would go the other direction, right? So if I were to do negative, it would go this way. The curve would go that way. It would flip it around. If I put like a negative 1/4 in there. Okay, domain, same, all real numbers because it goes on forever to the right and forever to the left. Range is also all real numbers because it goes up forever and it goes down forever. So that's an easy domain and range for the cubic. Okay, so this is how you transform a cubic equation. This is the parent graph. This is the transformed function. And that's how you move it around and stretch it. And this has a vertical compression because of the 1/4. All right, so that's the 4th graph. Let's see, we're moving, we're doing good. Let's do a square root next. Okay, so we're good with that. I'm going to clear my drawings here. Okay, top of the next page. So this is the third page. This is number 5. I'm going to number it. This is the 5th graph that we've done, top of the 3rd page. And we are doing square root. Square root. Okay, so our parent graph is y equals the square root of x. Okay, so if I take the square root of 0, I'm going to get 0 in my table. I take the square root of 1, I'm going to get 1. If I take the square root of -1, we don't have that, right? We can't do any negatives here. Question, there's nothing here. Although in your notes today, you are going to talk about there is a square root of -1. We can't graph it right now, but so right now there's nothing in the negatives, right? Square root of 2 is like 1.414, so I'm going to put 1.4. Square root of 3 is 1.73, I believe. And then square root of 4 is 2. That's a perfect square. Square root of 5 is like 2.1. Okay, so if I were to graph this, 0, 0 is right here. Put an open circle. 1, 1 is right here. 2, 1.4 is a little higher. 4, 2. I gotta skip 1, go to 4, 2. And then if I had room, the next perfect one would be 9. It would go 9, 3, right? So if I had room to do 9, 3, like way over here. So this is the graph, right? That's 9, 3, and 4, 2. But my locator point is at 0, 0. So this graph, you guys, is a curve. Okay, and the curve keeps going up, 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 up. It doesn't ever flatten out, so this does not have an asymptote. Okay, it goes up, up, up forever towards infinity. Okay, so it's basically like a half parabola. If we could do the other half would go down here, and we are going to do what's called a sleeping parabola later. So, but it doesn't have a bottom half for this one. Okay, so no symmetry, right? No symmetry. Endpoints, yes, it does have an endpoint. Let's put our equation. Y equals a times x minus h, and the h is underneath the square root, and the k is not, plus k, like that. That's how you're going to transform this function. Okay, so transform graph. Y equals 3 times the absolute value of x plus, square root of x plus 2 minus 4. The minus 4 is outside. Okay, so this is going to give us our HK, our locator point. Okay, we take the opposite of because this square root is like parentheses. So this is our H, this is our K. H is -2, K is -4. So -2, -4 is down here, -4, -2. And then we're gonna get like a curve, unless this is negative. If this was a -3, then I'd go down. Okay, but it's not negative, so I'm going to undo that. So we would want to plug in numbers, and when you plug in numbers, I'm going to go over 1 up 3 from here. So over 1 up 3, okay, because it has a stretch factor of 3, so up 3 over 1, and then up 3 over 3 happens to be the next one, up 3. The only way to know this is to make a table and actually plug them in, which I would do with you. It just don't have extreme time. So you can see that this one is a lot wider than this one because it has a vertical stretch of 3, right? So we're going to have a domain and a range. Okay, So our domain is from actually here to the right, right? So that's -2. So x is greater than or equal to -2. Our range goes from here up. That's at -4. So y is greater than or equal to -4. It doesn't have any asymptote. Well, I don't know. It kind of has an asymptote like right here. I wouldn't necessarily, I mean, you could draw it in, right? That's to show you. And I guess you could draw asymptote. You could draw two asymptotes going through the locator point, like a vertical one and a horizontal one going through the locator point. That kind of would help you. That's kind of a box that it's in. It's going to go up forever here, to the right forever here. So that'll kind of help you. So kind of an asymptote. It does have an endpoint, right? Its endpoint is this locator point right here, -2, -4. So yeah, it has an endpoint. Okay, so square root functions have endpoints. They have like a point and then they go whoop like that, or a point and whoop like that. Or it could go the other way. It could go that way, and it could go the other way like that. Okay, but no, for mostly ours are going to go this direction or that direction. We're not going to flip it around yet. So let me erase that stuff at the bottom. You don't need to draw that. Okay, we're good with that one. Oh, I don't think we're ready for the sleeping parabola, but we can do the exponential. Let's do one more. Let's do exponential. Then we'll probably stop after this. Okay, so down here, I'm gonna move my paper
So
down.
will we be done after this?
I'm not sure. We have a couple things to cover. Do you have somewhere to go?
Right. No, I was just wondering. Thank you for letting me know though.
Yeah. Number 6 here is the exponential. Okay, parent equation. Y equals b to the x power. Okay, and if you recall last time when we did the work, we let b equal 2. So I'm going to put like y equals 2 to the x for our parent graph, because we need to put a value in there to graph it. But it could be, you know, it could be 3 to the x, it could be 4 to the x, it could be 5 to the x, it could be 5.5 to the x. B needs to be a number bigger than 1 though. Okay, so let's make it 2 to the x here. So if I plug in 2 to the 0, that's going to give me 1. If I plug in 2 to the first power, that's going to give me 2. 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. 2 to the fifth power is 32. It's going to notice their numbers are doubling. Okay, 2 to the -1 power. 2 to the -1 power is 1/2. 2 to the -2 power is 1/4. 2 to the -3rd power is 1/8. Sorry, I almost said negative. It's not negative. These are all positive numbers. 1/8. 2 to the -4th power is 1/16. And 2 to the -5th is 1/32. They're all positive numbers, no negatives. Negative exponents are not negative powers. So those are all the reciprocals, right, of these numbers. So like 1/8 goes with 8 is the reciprocal, 1/16, the reciprocal 16. This is the reciprocal of 32 and whatnot. So if you graph your exponential, 0, 1, that is your locator point, okay, where it crosses the y-axis. So this guy right here is your locator point, 0, 1. Then 1, 2 is your next point. Then 2, 4, 2, here's 4, 2, 4. And then 3, 8, here's 3, and then 8 is right above the graph. So like right there, not there, right there. And then it gets closer. So this 1/2 is right here, 1/4, closer and closer to the x-axis, but never crossing the x-axis. So it looks like this. Okay. It will never cross the x-axis. So does this have an asymptote? Absolutely. Do you need to draw the asymptote? Absolutely. So we're going to draw the asymptote in on the x-axis. The x-axis is the asymptote. Okay. So we're going to change the asymptote probably for our transformed graph, but it definitely has the asymptote. We need to draw it. And 0, 1 is a locator point. That's super important. Wherever it crosses the y-axis is your locator point. Okay, equation to change this, to transform it, y equals a times b to the parentheses x minus h, that says x minus h right there, plus k, big K, all the way on the right. So the x minus h is your exponent, right? This is exponent, it's small. And the k is not an exponent, it's big. Example equation, y equals 3 times 2 to the x plus 2 power, that's exponent, minus 4. Okay, that's my example one. And so what is our hk? H comma k. Okay, we're going to do the h is the opposite of the number with the x inside the parentheses. So this is your h, opposite of h, and this is your k over here. So opposite of positive 2 is negative 2, and then your k is negative 4. So this locator point is going to move from 0, 1 to, wait, I'm not going to move it from 0, 0. Okay, so I'm not starting at 0, 0. I actually need to start at 0, 1, right? And I need to go to the left 2 and down 4. Let me check this. 2, 4. Where does that put me at? That puts me at negative 2, negative 3. Is that correct? Negative 2. Let me check, double check something. Negative 2. No. Oh yeah, okay, that's the graph. You know what? I actually do, at negative 2, negative 4 is gonna be, so that's a point on my graph, right? That is actually a point on my graph. Now, if I were to move this asymptote, right? This asymptote was here, was at x, but I want to move it down 4 units because of the minus 4. So my asymptote is going to be here, going through negative 4 like this. Okay, because you move the asymptote down 4 because of the minus 4 right there. All right, and points that we have graphed. So my locator point, so okay, they're saying that this is our locator point, negative 2, negative 4. So that's like my negative 2, negative 4. This is they're saying this is the locator point, but your graph is just still gonna go like this. And it's not gonna go through 0, negative 1. It's actually 0, 1, it's actually higher than that. And it doesn't run into the asymptote, so make it so it doesn't run into the asymptote, okay? And we should plug in some numbers in here. You know, we should make an XY table and plug in some numbers. Like if I plugged in 0, 0 would be a good number to plug in, 0, 1, 2, negative 1, negative 2, so on and so forth. If I plug in negative 2, I'm gonna get 2 to the 0 power, which is 1, and 3 minus 4, which is negative 1. So negative 2, negative 1, like right there. That's where I had the dot. Okay, it actually goes through there. It goes higher, goes more like this. Okay, so yeah, plugging in numbers would be helpful for that one. Domain goes forever left and right, right? It goes forever this way and forever that way because it's an exponential graph, so that's all real numbers. The range stops, so y is greater than negative 4. It doesn't include negative 4 because there's an asymptote there, but y is greater than negative 4. And definitely has an asymptote. And you must draw it in, okay? And my asymptote line here is x equals negative 4. I'm sorry, not x, y. It's going sideways, so that's going to be y. So let me undo that. Y equals -4. Notice it's similar to the range, the asymptote. We're just going to be equal to though, because that's where your asymptote is at the line y equals -4. Okay, is there anything else I need to write with that? So you know what? I'm going to change this. We're making the locator point here 0, 0 on the asymptote, and we're moving it down 4. I would have made that the locator point. I would have called 0, 1 the locator point and that one. So there's 2 different ways to do it. However you want to do it is fine. But you need to move both of them. You need to move that point 0, 1 on the graph to get your point, and you need to move the asymptote. So either one is fine. Okay, but this is going to be on your asymptote, the way they have it done here. Okay. All right, so there are like 2 or 3 more, but we'll save that for next time. And hopefully we have power. The other thing that we need to do, hold on, let me pause this recording.